Okay. Recording. Hey, we're at another GOAT web series here. Really happy to have Matt Droter here with ROS Agriculture to talk about their work. And I'm joined by Juliet, Norton, and Ankita. So I want to do a quick round of introductions, but in general, GOAT is a gathering for open ag technology, and we're a group of technologists from across the spectrum that believe that by collaborating we can improve agriculture together. And I'm Dorn Cox, farmer and researcher, research director at Wolf's Neck Center, and co-founder of Farm Hack and GOAT and Farm OS operating system. Juliet?
Hi, yes, I am Juliet. I recently graduated from UC Irvine in the informatics department. At that department, I did research with two permaculture communities on researching their use of information tools and like their information challenges, and conceptualized and developed some information tools for them. And part of that included creating a plant database and ontology for perennial polyculture design.
And then Ankita?
Oh, hi, I'm Ankita. I'm a postdoc currently at the USDA's Agricultural Research Service for the Sustainable Ag Systems Lab. And this is my colleague, Brian, who will introduce
I'm a data scientist. Basically, I do the same thing as her, but more ag, less computer.
Yeah. And so we mostly work on cover cropping tools and data architectures for doing large-scale participatory research on farms. And yeah, happy go. Thank you for presenting today, Matt.
You bet. I'm Matt Droter. I'm the founder of ROS Agriculture. ROS Agriculture is a focused initiative of the robot operating system. So together our community is an online collaborative community, and we are empowering farmers with robotic tools.
Great. Well, we're excited to learn more. Are you going to want to do some screen sharing?
Yeah, I've got some slides we can go through.
Great.
Are you able to see the screen?
Yes.
Okay. Well, like I said, my name is Matt Droter. I'm the founder of ROS Agriculture. And ROS Agriculture, we are a focused initiative of the robot operating system. We're an online collaborative community that's creating an ecosystem to empower farmers with robotic tools. A little bit about ROS Agriculture and our philosophy. There's an old saying, if you want to go fast, you go alone. If you want to go far, you go together. The vision we see is fully autonomous food production, all done by robots in the future. So much like you see in warehouses today, with lights out manufacturing all done by automation and robots, that's moving outside. So our mission is to create an ecosystem that we can empower farmers with these new tools. Some of the values at ROS Agriculture is human capital development. So we believe that a human's mind and their creativity is far more valuable than their labor. Some of the guiding principles is good for humans. So are we reasonably sure what we're doing won't make things worse? We have a philosophy of truth. Now, today, the rate of change is increasing, and the best predictor of tomorrow is accurate picture of today. So we try to have intellectual integrity. Some things that we hold to be true today may not be true tomorrow. We have an expedition behavior. We understand that agriculture and farming and dealing with nature is extremely difficult. And we also understand that robotics is an extremely complicated field, but we choose the adventure. We take calculated risks and we embrace failure. Globally, agriculture is very diverse. So it's hard to imagine that we will have one robot that can solve all of the agriculture problems everywhere. So instead, we're focused on creating robotic tool set that the farmers can use at their location to solve their particular problem. Dealing with robots today takes a very wide range of skill sets. So we need people that understand electrical wiring, that can do machining, like to weld, because there aren't robots that you can go buy off the shelf. We're taking OEM machines and then modifying them to make them robots. There's a lot of software development in robotics today, and there's a wide range of software skills that are needed. So if you may be interested in microprocessors and embedded systems that use C or C++, or Python, or even web development skills like React for the front end. And let's say that you aren't into software development, we need data sets from your farm. So collecting image data sets and other information about your farm will help us with our computer vision systems and train AI and make the robots smarter. And we also have online virtual simulation environment. So if you don't have any hardware, you can still work with robots and test robots just using simulation. And this also allows us to have multiple people, 10 or 100 people, all work on the same robot at the same time. So what does success look like at ROS Agriculture? We're working on educational pathways to onboard and train people, not only in robotics, but also farming techniques and business development, so that they may go out and start their own ag tech business. We have meetups and informal training sessions in local communities. We also use online training schools like Code Academy for software development, Udacity for robotics training, and the Robot Ignite Academy for learning about the robot operating system. We can use our online simulator for virtual farming competitions to solve different problems. And we're looking at volunteer vacations where technologists can actually go out and get into the field and learn more about where the robots will be running around. And in the future, an annual ROS Agriculture conference. So I invite you to join the adventure. There are multiple ways that you can learn more about ROS Agriculture. We have an online Slack group that discusses robotics and agriculture. You can start or join a local meetup. You can start a project on your farm. You can build a tutorial or collect a data set or share a data set that you may already have. You can sponsor an automation project, provide a bounty for one of our virtual competitions, or you can join us at our weekly online meeting. So again, my name is Matt Droter, and this is ROS Agriculture.
Thanks, Matt. That was great. That answers that you incorporated some of those the questions that we have into your presentation. But I'd like to ask, from your perspective, like how you chose open source, and how has that really helped or hindered your efforts today, and sort of what's your history with choosing this pathway?
Yeah, I worked in proprietary development in agriculture robotics, and it's very difficult in that scenario to go out and talk and share and communicate ideas or talk about different problems. And in the open source community, I thought that was a huge advantage, because now if I'm stuck on a problem, I can share my schematic, I can share my software, and people can take a look at that. I can learn a lot faster. The other thing is learning. Like, let's say that you want to know how to do something. Well, if it's all proprietary, that is a barrier to entrance. So open source software and open source robotics, it makes it the way to learn.
What have some of the challenges been in moving in this direction with open source research and development?
Well, I think it's common with any open source project. It's just kind of understanding where the software is or where the technical capability is, and then what we can do with that. And so we always want it to be better and easier and faster, but the truth is we are where we are.
I'm wondering if you might describe a little bit about some of the, the participants and the really active working groups within ROS and Slack. And I've had the pleasure of joining you on some of your weekly meetings and seeing some of that. But it'd be great to hear sort of where the areas of excitement are right now. And
we're currently working on a small lawn tractor. We've got about 4 different people working on a small lawn tractor automation platform. So that's basically teaching us the principles of automation. How do you get control of it? How do you drive it around? And it's a smaller platform, so it costs less and it's safer to move.
And we had talked a little bit about sort of using sort of off-the-shelf platforms as a research sort of tool to limit the numbers of. Do you want to maybe say a little bit about sort of your thinking as far as the types of systems that you're trying to test on that and what you're trying to sort of leave for later?
Yeah. So kind of the goal, the minimum viable product is to be able to provide people the information and the software and the electronics and the hardware so that they can make their own self-driving vehicle. Now there are platforms that are available that you can buy commercially off the shelf. They are generally the smaller units, maybe run $1,000, $1,500, and then the bigger units can range all the way up to $20,000. So with these small lawn tractors, what we're found is that they're widely available. You can get these things everywhere, all over the world. And you can get them used and broken. You don't necessarily need to have the latest, greatest to start learning. So it's a really low-cost option, but the 18 to 22 horsepower engine on them gives you enough power that you can do real work.
Right.
I have a follow-up question.
Mm-hmm.
So at least in software, we have the benefit of having a very low cost of what we build, whereas when you're dealing with hardware, there is a lot of capital that's required. So what is the process that you've gone through for going from identifying a need and then actually building out a team to then work on putting together a schematic, the hardware, the software, identifying parts? Like it's a pretty complex system. So what's that process look like for you guys? And how does costing fit into all of that?
Yeah, that's a great question. So we have weekly meetings online, and then we will share a problem or how do you do this, or how do you get, for example, steering. How do you get control of steering, and what would you use? And then people talk about the different ways that they have automated vehicles in the past. One we're using right now is the electric power steering out of a car. They run about $60, and they're very strong motors. It works perfect to control steering. And then you need to understand where your wheels are pointing. And so we use like a $5 potentiometer for that. So there is that trade-off between the cost. So we use a Raspberry Pi for the brain. So you are limited on space and processing power, but these are very capable machines, our computers. And then just use Arduino or Arduino compatible board, which are very low cost, and you can get these everywhere to read and monitor your sensors. So there are some trade-offs, obviously, between accuracy and cost. But
so you're taking a component-based design approach to this whole adventure, and so that way people can plug and play pieces as their budget allows?
Exactly, yes, or that they can get. So we have developers in Egypt, and they are limited on the availability of components.
Okay, and so how large is the entire community? I'm excited to learn more about you guys, and I would also love to learn a bit more about the provenance. How did you come to be?
Well, the ROS Agriculture community is about 200 people. We're in 16 different time zones, and it varies greatly on the aspects of agriculture. As diverse as ag is, we have people that are working on different parts. Even like in South Korea, they're working on food computers. So these little greenhouses, basically, that run on your desktop. And then the greater community is the robot operating system community. Now that's about 60,000 developers worldwide. So ROS is used everywhere in the world. So we are basically like a subset or a focused technical initiative out of them.
That makes much more sense. Okay, cool. Thank you.
You're on mute.
So I wanted to follow up more on sort of on this hardware challenge of sourcing appropriate sensors and interoperability because there's interoperability hardware issues, but also on the software drivers for those, and just some questions about sort of follow up on Ankita's approach for how are you handling documentation of that and exchange and sort of working through some of those challenges.
Okay, that's great. Great question. That's always serious issue when dealing with computers and software. And thankfully, we're not isolated. We have that greater community of developers that are making the software. So there are a lot of people in the ROS community that use the Raspberry Pi. So they make the binaries. They have the build farm servers. They do the quality checks, and so that. We are just following along their process. They've laid the groundwork for us.
And what tools are you using for collaboration? You'd mentioned Slack, but are there others, platforms that you're using for your repository and project management that would be?
Yeah, GitHub. We use GitHub, so all of our software is out there, and there's project management tools inside of GitHub. We also use Google Docs for storing files. And we use the Robot Ignite Academy has an online ROS simulator, so you can do full development and share projects and share software pieces. And we also have our own simulator that you can download on your machine and run.
Great. And how is Ankita, were you going to jump in?
I was going to ask a question, but it has more to do with this idea because you have this larger community, and it seems like there's a lot of interest in sort of robotics for space exploration, and that's also a resource-constrained environment. I'm always curious to learn, agriculture is also a resource-constrained environment where there are resilience challenges, and you also want that repairability. How do the different communities interact, and maybe what are some lessons that you've seen cross-pollinate between these communities? And I'm assuming yes, but.
Yeah, absolutely. I know that you may think that so there is obviously humanoid development in ROS, and then they use that for Mars simulation. So they just had a competition for a humanoid running on Mars, doing different tasks at the space station. And so this was all done in simulation with all automated checks, with automated random generated scenarios. That same tool set or that same pathway can be directly applied to agriculture. So they are cross-pollinating any of these technologies that are being developed. We can just create a different world instead of Mars, or we could even add to it, have the humanoid farming on Mars.
So I guess then a wrinkle follow-up question would be that on the terrestrial context, we also have all these other sociopolitical systems, economic systems that also come into play. And there's always a discussion about the tension between labor and automation. And I was just wondering if your community sort of deals with these sorts of issues or has values or stances on these sorts of issues that influence the way in which you design systems?
Yeah, absolutely. I would say around safety is a big concern. Nobody wants to hurt anyone, so that's a big issue. One of the reasons for the smaller platform and we have a safety system. And then second is kind of the principle is good for humans. Is what we're doing is this making it better for humans? And what we find is that you obviously you're in agriculture, so you know that the people that grow our food are the people who are most food insecure. We want the cheap labor, and so that's a problem not only in America but all over the world. So by using the human brains, I mean, can you imagine training these kids instead of getting them into agriculture, getting them into robots to do agriculture? It's just a new tool. Instead of using a hoe, we're going to use this little teeny engine and these little parts, and we're going to learn to build software, and you're going to try to figure out how to make this robot do the work that needs to be done. And those skills are transferable. So once they learn these programming skills or robotic skills, they can use that in any field they want to, but they have the opportunity to stay on the farm and use high-tech tools.
Cool.
Yeah, and I'm wondering how you're handling those questions of this balance that Ankita and you were just discussing of between sort of robotic assistance and full automation, and the role of sort of the sensory sort of enhancement or mechanical enhancement versus, again, sort of full autonomy in independent vision. And sort of the question is both how you feel about that, but also how is that discussion handled within your community, or those kinds of discussions and sort of governance of the projects?
Yeah, that's a great question. Those are those are interesting conversations, and I think that one area that you can use as sort of like a weather balloon is the on-road vehicles. What are the conversations that we're having around that? So a couple of years ago, they came out with 5 levels of autonomy, and then they talked about, okay, some self-driving car companies decided we're going to go to level 3 autonomy, driver assist, lane change warnings, adaptive cruise control. Level 4, we're going to take more of it away from the operator to level 5, fully autonomous. Other companies like Google said, no, we're going to go from level 1 to level 5. Because what they found is that, if you're in a level 4 or level 3 autonomous car, you stop paying attention. You may start reading a book or playing around with your cell phone. And then when the operator needs to take control of the car, they've lost the contextual awareness. And so it's actually unsafe to have a level 3 or level 4 car. So we do have farmers that are getting older and they are losing depth perception, and so they're having a hard time seeing exactly where that implement is in the back. And so they are interested in just like a little vision system or a GPS system so that they know relatively where they are. So you could see some of those kind of driver assist technologies come online, but definitely the real goal is to get people's brains activated and not their labor. If we have a clothes washing robot, if somebody wants to wash their own clothes, they can. There's nothing wrong with that. But most people choose to let the clothes washing robot take that task. And farming, most of the farming tasks will be like that, I imagine.
I'm also, and I'm particularly curious about sort of the environmental sensing and the feedback, because there is a sort of a human element to understanding the landscape and the robot and the sensing system and interface, sort of that, because there is still a human interface to what the robot is accomplishing. So again, is that something that is something that is a goal that's been discussed in your community? Or
about what's the level of involvement for the human?
Yeah, sort of environmental feedback. So sort of the human sort of interaction with that autonomous action. I'm just curious.
Yeah, so this is brand new territory. People don't really know what to do. There's a term or a concept called supervised autonomy, where we'll have these robots out running around, and then the human will be there monitoring what the robots are doing. Other companies are just going fully autonomous. You don't really need it. You just don't. The computers are very smart, and over the next 12 years, expect them to get extremely smart.
Yeah, and I bring this up partly to prime Ankita here, because we're having a lot of conversations on the software side of terms of trust and human-centered design and creating connections where the technology facilitates sort of the human experience. Because certainly what the robot needs, it can live in situations that don't require that, but we still require trust and interaction to sort of make our own decisions there. And so that's why I'm particularly interested in that. And I think
robot interaction.
Well, sort of again, the technology enhancing the human experience. It can substitute, but that can also, and the robot doesn't need it, but perhaps we do. And so that's my prompt.
Yeah, I think it's hard to imagine in our future world. This is just my opinion, not saying it's real, but look at the blockchain and some of the things that we're dealing with that. So it handles a trustless environment. And I would see our future as that. As we get more intelligent machines, smart machines, they're going to be talking to each other. We need a trustless infrastructure. And we need identity. We need to know who's doing what, where, and then privacy. So those are the three things that cryptocurrency, that idea of blockchain handles. And those types of tools I see are in our future. So a trustless system.
Are you going to jump in, Ankita?
I was just going to ask that, are there other similar technologies that you see as paired with your goals, things that you require others to be pushing forward in order for you to sort of achieve this vision that you have or your community has for robotic agriculture?
Yeah, I would say everything.
Give me a couple that I can sort of chew on for a little bit.
Okay, I think like data sets. We're training artificial intelligence to identify weeds in crops. So accurate data sets over time are important. If you want to see how a disease progresses, you can see where it is in your field this year, but it's really neat to see how that disease moves through your field over a 5-10 year period. So even though you may not have the infrastructure at your farm to process or to train those models, collecting data today will give you a leg up.
And along with that, I imagine, Juliet, some ontologies to make all that those larger data sets talk to each other.
Well, yeah, I had a couple of questions, not specifically regarding that, but following what Ankita had just asked, what are some of the most challenging contexts or applications that you guys have faced so far? You had mentioned, just a moment ago, needing data sets, but I was wondering, what about?
Yeah, exactly. So
I'm so sorry, but what about are there other things? Are there other forms of information or hardware or even just like human involvement that you have found so far as a major conflict for like developing some of your goals?
Or
I think,
opportunity.
Yeah. The limiting factor or opportunity is people, so their brains. We need a lot of software developers. If you're into data, we've got data sets. If you're into artificial intelligence, we're working on a pipeline to train models. So there's different teams or aspects. We need electrical engineers. We're working on trying to put these low-cost components together. So any interest that you have can be used. You just join a team, and so we can start working on the problem.
So that actually brings up another question with all open source projects: is how is this project sustainable, and how is it supported as a business or as infrastructure and so forth?
So we are looking at different models for monetization and open source. That's always an issue. So we're looking at education through training and then through sponsors.
So how is ROS Agriculture and ROS in general? How is that community initially sort of supported?
It was started at Google, and then it was Willow Garage and spun out after that. And so it's open source, and now they do get government funding, and they have focused technical initiatives. So DARPA was a big funder. I think about 25% of the funding for a few number of years came from DARPA.
And ROS Agriculture is a subset being supported through ROS?
No.
Nope.
So we're just a focused initiative, a community, a sub-community. So there are a number of sub-communities inside of ROS. For example, there's ROS Industrial, and they're focused on robotic arms and manufacturing.
Mm-hmm.
So
which we like that because we can use the robotic arms for harvesting.
So riffing off of that idea, given that there are certain domains in which robotics have really excelled, are there particular types of production systems or parts of the food system that are more accessible for doing early stage robotics work?
That is a great question. I don't know the answer to that, but I imagine that there is. We've been talking a little bit about that, instead of going for the full self-driving car, a full self-driving tractor, is there a smaller or a sub-piece that can provide value to the farmers now with the current technology? It's a good question.
And then in addition to looking for developers and people who want to sort of build stuff, I'm guessing that maybe then you're also looking for domain experts and people who have the problems
yes.
In the domain. Because at least that's the approach that I've been taking, which is I'm not a domain expert in agriculture, but if I talk to them and reach out and have that discussion, then at least I can begin to better design for that space. So it seems like you might have an analogous challenge in ROS Agriculture.
Yes, we were even looking at things like a chicken tractor. A chicken tractor needs to be moved every day, but if you make that autonomous, then you're saving the farmer like maybe 30 minutes. They've got to get out to the field, move it around, and do all that. But if it's continuously moving through the field with a very low-cost system, maybe $200 system, or under 500, let's say, if you save a farmer 30 minutes a day, over time, over a year, 6 months, that pays for itself. So what are some of those technologies that we can do? Maybe you can't replace a full person, but can you replace maybe a 15-minute task or a half an hour task or an hour task?
So then perhaps the challenge for y'all might be actually identifying those bite-sized tasks that can be augmented using automation or robotics, but that not necessarily affect the bottom line human venture that is existence and eating and life and stuff.
Yes.
So, and that was actually one of my other questions. It seems certainly that identifying new use cases is one of the interactions that you're looking for from broadening the community. And so my other question is sort of, are you aware of other sort of projects within the goat community or related communities where you've talked a little bit about some of the sort of the potential needs that you're looking for or potential intersections. So sort of riff a little bit more, I think, on sort of how our community and related communities like FarmHack and others could be helping support and identify those key problem statements or use cases.
I think like Ankita said about cross-pollinating, it's just kind of being aware of the two communities, and then you've got Farm OS, and so maybe there's some sensors that we can use to start uploading that data, or on soil collection or soil processing or analysis. Maybe we can put that onto an autonomous vehicle. And so it's just kind of being aware of what robotic tools we have, what the tool set looks like, and then how we can start to merge and use those together, building a bigger system.
Yeah, unfortunately, Greg wasn't able to join us today in the RSI lab, but I think that will be an exciting follow-up conversation in terms of rapid soil sampling. And also, I imagine the work that they're doing where it maybe intersect with ROS in general is sort of lab automation too, which could be internal to the robot or desktop sort of sampling procedures and so forth.
I almost wanted to suggest even going in the other direction, which was automation of certain kinds of field research, right? So at least for the folks that I work with, there is a lot of field research that does require sort of very small tasks to be repeated, and some of those are ripe for automation. And so I know, at least in the ag research community, there is interest in trying to think about ways in which we can use robotics and other types of platforms to collect data at scale in a distributed fashion. And so that might be a fun thing to maybe just sort of chat about at a later date, is opportunities for using robotics in large-scale field research or distributed field research, either one.
And certainly we were also talking, Ankita, about the intersection with some of our sensor networks that can interact in some of the communications protocols, and that we're working on with low network connectivity environments and so forth, that there could be some similar challenge statements or problem statements that we're looking at trying to solve that will work in those environments. I'm also curious about licenses and what you're generally using within the ROS community, whether there's a range, and what kind of flexibility you have as you're looking at open source licensing and approaches.
Yeah, so there are a number of open source licenses. We've been using MIT, so just full open source license on that. There are different packages. So there's the ROS core, and that ROS core software is all MIT. And then there may be some specific packages that are built on ROS that have commercial licenses or different types of licensing.
And are there other open source communities that you're actively engaged with that sort of that where you're commingling those different approaches and intersecting with the sort of? And I guess the other question on the edge of that is where do you intersect, and how do you handle where you get into, sort of, say, proprietary user interfaces and so forth? Or has that come up yet?
To some extent. So we use the Raspberry Pi, and that has a huge user base. So anything that you want to do with it, somebody's already done and posted a tutorial on it. And then we use the Arduino also for sensors. So that's a very large open source community that we can pull from. And we do have ag tech companies that participate, professional companies that participate in ROS Agriculture. So there are some proprietary things that they are working on, but most of the we've talked about a little bit, and most of the base software of just getting your vehicle moving, that is already in the open source, so there it's not their secret sauce or part of their system. But that's always an issue. We're just trying to work through that, and we have a pretty widespread group, so it's not like that they're competing directly in the same community with each other.
Great. And I guess just to come back to the hardware sort of documentation, you mentioned that you're using primarily GitHub. Certainly there's different documentation standards for the electronic sort of circuit design versus mechanical design. Are there standards that you've come across that have been particularly useful for sharing, say, mechanical design and so forth? Or is it in 3D design files, or how is your community handling some of that that iteration process?
Great question. So we've had a few meetings talking about that. We don't have a big engineering group that is kind of formalizing that process. We went through and kind of looked at our software development process, but on the electric side, Fritzing, we've been using that for schematics, and then I think it's like FreeCAD. We've used FreeCAD before. I'm not a mechanical engineer, so I don't know too much of this software. And there's another one that people have been using to share files for the 3D printer. So if they want to make a bracket for that, they can share that.
So generally in an STL file or something, or yeah. Great. Yeah, that's Ankita, do you have some other?
I have a potential wrap-up style question that might be that I'm curious about, that has more to do with thinking about what what different projects, maybe just giving a couple of examples of other projects that are active that are sort of ripe for community involvement. So if I were looking to start getting involved or working with a particular group, where would I look? How do I get started on that sort of process? Because it is kind of exciting to know that there is a community already doing stuff in the robotics space.
That's a great question. So we have got the main community meeting for ROS Agriculture is on Tuesday nights at 6 p.m. Pacific, and that's just a Zoom call. And then we have a lawn tractor group that meets on Friday at 12 p.m. Eastern. We have a perception group that just formed, and we are working on a data pipeline and a training pipeline for vision system, artificial intelligence. And then we have like a path planning group. So it depends on kind of what your interests are and then your skill level and what you're interested in. We also have another group that's working on the safety system. So if you are interested in...
And we can post... We'll post links to those along with the video for the goat community. And how do folks join your Slack group if they're interested?
They can go to our website at rosagriculture.org and then sign up through there.
Very simple. Well, and I guess I'd also like to give Ankita a chance to pitch the upcoming goat hack that's coming up. We may have a chance to dive in a little bit more in person. So we have both Juliet and Ankita who are key organizers for that. So maybe you might want to sort of say a little bit about that. That's coming up, and I think we'll probably wrap up after that.
Cool. And I think, Matt, you are joining us, it sounds like, at potentially?
Potentially, yes, working on that.
Cool. Awesome. Well, so I guess we are having a hackathon on April 4th and 5th, and it is definitely the wrong way around for all of you who are watching. But the information is available on our website, goattech.org. And our theme this time around is going to be looking at how we can build data pipelines and tools for public ag research. And so we're hosting it here at the USDA's Ag Research Service. So it'll be, I can see the building in my mind 3 streets down from here. And it should be a fun group. We have about 40 people coming so far, and I'm hoping that we can start to bootstrap a couple of different projects. And so if you have an idea, if you just want to chat, send me an email, and I look forward to seeing you all there. And everyone on this call, so I look forward to seeing you there.
Absolutely.
Cool.
Well,
Thanks, Jordan.
Yeah, well, thank you all for joining us today, and we'll look forward to the Goat Hack and to seeing Matt at the Goat Hack and diving in and linking some of these different projects together, and lots of cross-pollination. Thanks so much.
Thank you. It's a great meeting everyone.